Hello everyone, this is Mr. McMillan and I'm here with the instructional video for today on finding angle measures and side measures in quadrilaterals. So now that we've covered the properties of quadrilaterals, we can use this information to determine missing side lengths and angle measures of various quadrilaterals. We'll be using the property chart that we completed to assist us. We completed that in the previous video. The first type a problem we're going to be dealing with is the angles in trapezoids. Now, there's a general rule for determining angles in trapezoids, and there's one that only applies to isosceles trapezoids. So the general rule is that each pair of lower base and upper base angles are supplementary. So each pair of lower base and upper base angles are supplementary. This means the measure of each pair sum to 180 degrees. So that's true for any trapezoid. Doesn't matter if it's isosceles or not, that applies to any trapezoid. Okay? Then there is a specific rule that applies only to isosceles trapezoids, and that has to deal with each pair of lower base angles and upper base angles. So the lower base angles are congruent, and the upper base angles are congruent. Okay? So the lower base angles are congruent, the upper base angles are congruent. So that means that if they're connected by the same side, the same base, then that means they have to be congruent if it's an isosceles trapezoid. So let's look at some examples here, and there are 8 examples. Number one, we have trapezoid WXYV, and we're given angle X, and we're given angle Y. Now the important thing here is we need to make sure which type of trapezoid we're dealing with, whether it's just a general trapezoid or an isosceles trapezoid. Now remember, isosceles trapezoids have 2 congruent sides. So they have 1 pair of congruent sides on the legs. And so we would see markings or side measures there that would indicate that. Well, as you can see here, there are no side markings here on WV and XY. So this is not an isosceles trapezoid, it's just a regular trapezoid, it's a general trapezoid. So if we look at X and Y here, we see that X is our one of our upper base angles, and Y is one of our lower base angles. Now, since we have 1 upper base angle and 1 lower base angle, that means, and they're connected by the leg, then that means that these are supplementary. So the measure of angle X plus the measure of angle Y must equal 180. Well, we know the measure of angle X. We want to find Y. So we have to take 180 and subtract the measure of angle X, which is 117. And if we do that, we get that the measure of angle Y is equal to 63 degrees. So upper and lower base angles that are connected by the same leg are supplementary. Now I'm going to write that up here. Angles are connected by the same leg. Okay, now let's look at number 2. So again, number 2, we have angle W and we want to find angle U. And so we determine, is this a general trapezoid or is it an isosceles trapezoid? Well, we can tell by the 2 side markings here that these 2 sides are congruent. They are on the legs, so that means that this must be an isosceles trapezoid. Now, you'll notice here that W and U are across from one another. So we're going to have to find other angles before we can find what U is. So we know that since this is an isosceles trapezoid, the lower base angles have to be the same. So in this case, U and X are your lower base. So they are congruent. And we also know that the upper base angles have to be congruent as well. So what we can do to find angle U, we can find either angle X or angle V, and then we can find angle U from those. I'm going to go for angle X because I know once I find X, U is exactly the same. So angle X forms a supplementary pair with angle W. So that means that angle X has to equal 180 minus 125, which is 55 degrees. Now, since this is an isosceles trapezoid, we know that the measure of angle U has to equal the measure of angle X. So that means the measure of angle U is also 55 degrees. And just in case you're curious, angle V also equals 125. Okay. All right, number three. Number three, are we dealing with a regular trapezoid or an isosceles trapezoid? Well, we have isosceles trapezoid because the two legs are marked as congruent, and we have angle D and we have angle A. Now, since we know it's an isosceles trapezoid, if both of those are the same type of angles, like the base angles, then that means they have to be congruent. So are angles A and D the same type of angle related to the base? And if you look here, yes, D and A are both lower base angles. So that means the angle D is congruent to angle A. So that means that the measure of angle A must equal 69 degrees as well. And the reason I call this the lower base angle, even though it's higher up, is because it's the acute angles. Okay. Number four, are we dealing with a regular trapezoid or an isosceles trapezoid? Well, we can clearly see that this would be a regular trapezoid. And we want to find angle G, and we have angle F. Now note that there is a box in the corner, which is a 90-degree angle. And angle G and angle F are connected by the same leg. So that means that they are supplementary. One's an upper base, one's a lower base. So that means that angle G plus the measure of angle F has to equal 180. And to find the measure of angle G, we have to take 180 and subtract F, which is 90. So the measure of angle G must equal 90 as well. Okay. So what I want you to do, I want you to try numbers 5 through 8. So pause the video, come back, check your answers using the video. So let's look at number 5. Number 5, we have angle V and we want to find angle T. And we notice that these angles are across from one another. We also notice that there are side markings on the legs, which means this is an isosceles trapezoid. And since this is an isosceles trapezoid, we know that the lower base angles are congruent. So angle V is congruent to angle S. And the upper base angles are congruent. So angle U is congruent to angle T. So I'm going to find angle U, and that will give me angle T by default. So angle U and angle V form a supplementary pair. So angle U has to be equal to 180 minus 74, which is 106 degrees. Since angle U and angle T are both upper base angles, that means the angle T must also equal 106 because they are congruent. Number six, we're given angle D and we want to find angle E. And we see here that we don't have an isosceles trapezoid, we just have a regular trapezoid. So angle D and angle E are connected by the same leg, which means one's an upper base angle and one's a lower base angle. So that means that angle D plus angle E must equal 180. So to find angle E, we take 180 and subtract angle D, which is 98 degrees. And if we take 180 minus 98 degrees, we get that the measure of angle E should be equal to 82 degrees. Number 7 is very similar to number 5. We see we have angle W and we want to find angle U. Well, since this is an isosceles trapezoid, we can tell it's isosceles because of the two congruent pairs or congruent sides. We know that angle W is congruent to angle T and angle V is congruent to angle U. So just like before, I'm going to find angle V first, and that will give me angle U because V is congruent to U. So angle V has to equal 180 minus 50 degrees, which is 130 degrees. So the measure of angle U must also be 130 degrees. And if you're wondering, T would be 50 degrees. And number 8, we're given angle D, and we want to find angle C. This is a regular trapezoid, not an isosceles trapezoid. So C and D are connected by the same leg, which means C and D are a pair of upper and lower base angles, so they are supplementary. So to find angle C, we have to take 180 and subtract angle D, and so we get angle C is equal to 140. And that's angles in trapezoids. Okay. The next thing we're going to cover is the angles in parallelograms. Angles in parallelograms. And there are 2 general properties that apply for any parallelogram and one that's specific to rectangles and squares. So the first general property is that opposite angles in any parallelogram are congruent. Okay. Do take note, these types of angles do not touch one another, okay? So they are diagonally across from one another. They're not connected by a side of the quadrilateral. Okay. The next bit here, consecutive angles, and it might also be called adjacent, so whichever way. Consecutive or adjacent angles in a parallelogram are supplementary. Note that these types of angles are connected by a side of the quadrilateral. So unlike the opposite ones where they're not connected, these are connected by one of the sides. Then there is an additional property that is unique to rectangles and squares. For any angle measure in a rectangle and square, it's always 90 degrees, which means that each one is a right angle. Okay, so just make sure you're aware of that. Now that doesn't change the fact that the opposite and consecutive angles still have the same properties in rectangles and squares. It just happens that they're always equal to 90. So let's look at number 1. We're going to do 1, 3, 5, and 7 together, and then we'll know what we'll do. I will figure it out. So number 1, we have angle D, and we want to find angle F. So since these are parallelograms, we are looking for whether the angles are opposite or they're consecutive. So let's look at angle D and F. Are they opposite or are they consecutive? So the first thing I like to check for is if they're consecutive. And are D and F directly connected by a side of the quadrilateral? And as we can see here, there's no way for D and F to be directly connected unless we draw the diagonal to them. We would have to draw two different lines to get to D, so F and D cannot be consecutive, they're opposite. So since they're opposite angles, that means that angle D must be congruent to angle F. And remember, congruent means that they have the same measure. So the measure of angle F must be equal to the measure of angle D, which is 100 degrees. All right, let's look at number 2. Number 2, we're given angle S, and we want to find angle T. And so again, since this is a parallelogram, we're going to determine, are these angles opposite or are they consecutive? Well, T and S, for them to be consecutive, they have to be directly connected by a side of the quadrilateral. Are they directly connected by the side of the quadrilateral? Well, if we look here, we see that they're connected right here. They're connected directly. We don't have to draw a diagonal or anything. So T and S are consecutive. Now, since angle T and S are consecutive, that means they are supplementary. So the measure of angle T plus the measure of angle S must equal 180. Well, to find angle T, we take 180 and subtract angle S. So we subtract 75. And if we do that, we get that the measure of angle T is 105 degrees. Okay. All right. Now let's look at number 3. Number 3, we have, we're given angle D and we want to find angle E. So we have to determine, are these angles opposite or are they consecutive? Well, are they connected by a single line of the quadrilateral without having to draw a diagonal or draw multiple lines? Well, if we look here, E and D are connected by this side here. So they're directly connected by the quadrilateral. So that means that these are consecutive. And since they are consecutive, that means that the measure of angle D plus the measure of angle E must equal 180. They're supplementary. So to find angle E, we take 180 and subtract angle D, which is 67. So 180 minus 67 will give you 113 degrees for angle E. And number 4, we're given angle C, and we want to find angle E. Again, we have to determine, are these consecutive or are they opposite? Well, angle C and E, are they directly connected by a side or would you have to draw a diagonal? And as you can see here, you would have to draw your diagonal. So that means they cannot be consecutive. That means they're opposite angles. So since they're opposite angles, that means that the measure or the measures have to be equal. So angle C is congruent to angle E. So since they're congruent, that means the measure of angle E must be the same as C, which is 58 degrees. Okay. So what I want you to do, I want you to try number 5 and number 6. Pause the video, come back, check your answers. All right, so let's look at number 5. Number 5, we're given angle A, and we want to find angle C. we have to determine if they're opposite or consecutive, and we can see that angle A is opposite of angle C. Opposite angles are congruent, so angle C has to be congruent to angle A. So that means the measure of angle C has to be the same as A, which is 125. And number 6, we're given angle A and we want to find angle B. We have to determine if they're opposite or consecutive. So we can see that A and B are connected by a side of the quadrilateral. So that means that these are consecutive. So the measure of angle A plus the measure of angle B has to equal 180 degrees. So to find B, we have to take 180 and subtract whatever A is, which is 106. 180 minus 106 ends up giving you 74 degrees, which is angle B's measure. Okay. Now, most of the time, it won't just outright ask you for what the angle measure is. Most of the time, it'll ask you to solve for X. So let's look at 7 and 8 to determine how we would set up those equations appropriately. So number 7, solve for X. And we have angle D and angle C labeled, okay? So like always, we're gonna determine if they're opposite or consecutive first. Well, D and C, are they opposite or consecutive? Well, angle D and C are connected by this side of the quadrilateral. So they're directly connected, which means they're consecutive. Since they're consecutive, that means they are supplementary. So since they're supplementary, we're going to have to add these two together and set them equal to 180. So 2x plus 75 plus 105 is equal to 180. And now we just solve for x. So on the left side, we can combine like terms. 75 plus 105 is 180. The 2x drops down. We want to get the 2x by itself, so we subtract 180 from both sides. And we get 2x equals 0. Still need to get rid of the 2, so we need to divide both sides by 2. And so we get x is equal to 0. And then number 8, we have angle E labeled and angle C labeled. So angle E and angle C, we want to solve for x. Are they opposite or are they consecutive? Well, if we look here, C and E are not directly connected by a side of the quadrilateral. They are directly across from one another on the diagonal. So that means that these are opposite angles. And since they're opposite, that means that the measures of the two angles are equal. So we have to take 13x minus 2 and set it equal to 50. And then we solve. So we're going to add 2 to both sides, and we get 13x equals 52. Divide both sides by 13, and we get x is equal to 4. Okay, so make sure when it asks you to solve for x that you set up your equation correctly. Otherwise, you're going to get completely the wrong answer. All right, and the last one here. The last thing we're going to cover in this video is the side lengths and parallelograms, and this is less complex than the angles. There is one property that we use pretty much all the time, and then there's another that's unique to rhombuses and squares. But regardless of the fact, the equations end up getting set up the same. So our first rule, the general rule, is that all parallelograms have two pairs of opposite sides that are congruent. So that means if the sides are opposite from one another, they have to be the same if your shape is a parallelogram. Okay, so that goes for any parallelogram, a parallelogram, rhombus, rectangle, or square. There is one unique to the rhombus and square, and that's the fact that all of the sides of a rhombus and square are congruent. Okay. All that's going to do is if your shape says this is a rhombus, determine the value of side EF or whatever. then what you're going to have to do is find x and determine that value, even if they're not opposite one another, but they're directly connected. So we're going to do some example problems here. We're going to do 1, 3, and 5, and then I want you to try 2, 4, and 6 on your own. So number 1, we want to solve for x, and we see that we have side AD and BC here. And we want to solve for x, and we know that these two are opposite from one another. So opposite sides are congruent. So that means that AD must equal BC. And that would also mean that DC would have to equal AB. So since these two have to be congruent, we have to set them equal to one another. And solve for x, so we subtract 1 from both sides, and we get 2x equals 16. Divide both sides by 2, and we get that x is equal to 8. It's important to note that the sides are only ever going to be congruent to one another because you cannot have a supplementary set of sides. Supplementary means the angle measures add up to 180, and of course, you know, we don't measure sides like we do angles. Okay. All right, number 3. Number 3, we have GF labeled here and HE labeled, and they are opposite sides, so that means they have to be equal to one another. So 16x plus 1 must equal 18x minus 1. I'm going to subtract 18x from both sides, and so we get negative 2x plus 1 is equal to negative 1. I need to get rid of this positive 1, so I subtract 1 from both sides. And so you get negative 2x equals negative 2. Divide both sides by negative 2, and you get x is equal to 1. Okay. Now some problems are going to ask you to plug in the value of x to find another thing, so make sure you pay attention to what the problem wants you to find. Like on number 5. Number 5, it says to find ST. So you'll notice here that RU and ST are opposite sides, which means they are congruent. So we're going to have to find x, and then when we find x, we're going to have to plug it in for ST. So we're going to set them equal to one another. So we have 4x plus 2 is equal to 3x plus 6. I'm going to subtract 3x from both sides, and we get x plus 2 is equal to 6. And then we're going to subtract 2 from both sides, and we get that x is equal to 4. Now we're not done yet because we want to find ST, and ST is given to us as 3x plus 6. So we take 3 times 4 plus 6 because our x value is 4. So we get 12 plus 6, which is 18. So ST is equal to 18. You could also plug it into the other one because you know these are the same. If you take 4 times 4, you get 16 plus 2 is 18, which was the same thing we got for ST. So I want you to try number 2, 4, and 6 on your own. Pause the video, come back to it, and check your answers. All right, so let's look at number 2. Number 2 wants us to solve for x, and we have ED and FC as opposite sides that are congruent. So we set them equal to one another. So 3x minus 11 is equal to 22. We're going to add 11 to both sides. That gives us 3x equals 33. Divide both sides by 3, and we get that x is equal to 11. Number 4, we want to solve for x again here, and we're given two opposite sides that are congruent. So 2x minus 2 is equal to x plus 7. So we're going to subtract x from both sides, and we get positive x minus 2 is equal to 7. Add 2 to both sides, and we get that x is equal to 9. And finally, number 6, find GF. So once we find X, we're going to have to plug X into GF. We see that these are opposite sides, so they must be congruent. So X plus 4 equals 3X minus 4. Subtract 3X from both sides, and we get negative 2X plus 4 is equal to negative 4. Subtract 4 from both sides, and we get negative 2X is equal to negative 8. Divide both sides by negative 2, and we get that X is equal to 4. Now we plug in 4 into GF. So GF is X plus 4. So that would be 4 plus 4, which is 8. And again, if you plug in 4 into here as well, you should end up getting 8. And that's going to do it for this video, guys. I hope this video helped you determine side lengths and angle measures in quadrilaterals. The side lengths were only for parallelograms, but you know, there is a worksheet. Make sure you work on that. It also has some classification stuff in there as well, which we covered on Thursday, I believe. So make sure you go through all that and understand all that. Okay. Thanks, guys, and I will see you in the next video.